Hey everyone, welcome back to my channel. Today we're going to tackle a medium-level problem on LeetCode, called minimum score of a path between two cities. This problem is all about finding the minimum score, or distance, between two cities in a graph. We'll be using a union find approach to solve this problem, and I'll guide you through it step by step. So, let's break down the problem. We have a number of cities and roads connecting them, each with a certain distance or score. We need to find the minimum score of a path between city 1 and city n. The problem statement is pretty straightforward, but the solution requires some careful thinking. Now, let's talk about the intuition behind this problem. Think of it like planning a road trip. You want to get from city 1 to city n, but you want to take the route with the minimum total distance. You can think of the roads as edges in a graph, and the cities as nodes. The core insight here is to think about the minimum score between two cities as the minimum distance in a path that can be used to connect these cities. Since we want to find the minimum possible score, we can start by examining the roads with the smallest distances first. Imagine you're a traveler, and you want to get from city 1 to city n. You look at a map, and you see all the roads connecting the cities. You start by looking at the roads with the smallest distances, and you try to find a path that connects city 1 to city n. As you examine each road, you check if the cities are already connected. If they are not, you add the road to your path, and you update the minimum score. This process continues until you find a path that connects city 1 to city n. And the minimum score is the minimum distance in that path. Now, let's dive into the code. We start by sorting the roads in ascending order of distances. This is because we want to examine the roads with the smallest distances first. We use a lambda function to sort the roads, and it's pretty straightforward. Then, we initialize a union find data structure, which is an array called parent. We iterate over the cities, and we initialize each city to be its own parent. We also define two helper functions, find and union nodes. The find function takes a city and returns its parent, and the union nodes function takes two cities and merges them into the same connected component. We iterate over the sorted roads, and for each road, we check if city 1 and city n are connected. If they are not, we union the cities of the current road, and we update the minimum score. We continue this process until we find a path that connects city 1 to city n. Now, let's talk about the time and space complexity of this solution. The time complexity is O m log m plus n asterisk alpha n, where m is the number of roads and alpha n is the inverse Ackermann function due to the union find operations. This simplifies to O m log m for all practical purposes because alpha n grows very slowly. The space complexity is O n plus m, where n is the number of cities and m is the number of roads. This is because we store the parent array for union find and the sorted roads array. And that's it, guys. That's the solution to the minimum score of a path between two cities problem. I hope you liked the explanation, and I hope you learned something new today. If you have any questions or suggestions, please leave them in the comments below. Don't forget to like the video, subscribe, and comment your approach below. Thanks for watching, and I'll see you in the next video.